Hello, this is Sai Sudha Amin. I've graduated in BSc IT and I'm a current student of MIL Academy. I'll be presenting on TCP connection establishment vulnerability, that is sink flood attack. Exploiting TCP connection establishment mechanism. The entire presentation is based on sink flood attack. Before we move on to sink flood attack, let's have a look at basic three-way handshake. When a client attempts to establish TCP connection with the server, it has to go through the three-way handshake process. It is nothing but when a client sends a sink packet to the server, the TCP is allocated on the server side. The server then responds with sink acknowledgement to the client, to which the client sends an acknowledgement to the server, and the connection is established. Sink flood attack. It is when an attacker sends succession of sink requests to target system, which fills the memory buffer of victim's system. Once this buffer is full, the host can no longer process new TCP connection request. Typically, the attacker uses spoofed IP address and exploit the three-way handshake process which we have seen earlier. Now let's have a look at resource allocation mechanism and the working of TCP. Why TCP is used. After receiving sink packets, the server allocates TCP, that is nothing but transmission control block, for incomplete connection known as half-open connection. TCP consists of all connection establishing details and resources. On contrary, client allocates TCP after receiving ACK and sink packet. This resource allocation mechanism can be exploited by the attacker. Now let's have a look at how this attack is launched by an attacker. The attacker sends sink packet with forged IP address which are either non-existing or unreachable. The server replies to each connection request with sink ACK packet but never receives ACK packet because destination address in sink ACK is unreachable as mentioned earlier. This connection stays half-open state until aged out. An attacker sends sink packets to target server at a high speed higher than that at which half-open TCP connection aged out. As a result of which, server runs out of the TCP resources and fail to provide further services, including to those who are legitimate users on the network. Now the question arises, how can we mitigate the attack? There are various techniques through which we can mitigate the attack, but the presentation would include two of them, that is sink cookie and safe reset. Preventing sink flood attack using sink cookie. Using this technique, firewall processes TCP connection request and adds a cookie that will help authenticate client in sink acknowledgement packet and validate the return acknowledgement. There are various steps in it. Client sends a sink packet to server. Firewall intercepts this sink packet which contains serial number and sends back sink acknowledgement packet along with the cookie. The use of cookie here is to authenticate the sender. After client receives sink ACK packet, it sends an ACK back to the server for final acknowledgement. If the results are same, that is the serial number, firewall then goes ahead and allocates TCP resources, if not discard the packet, assuming as invalid client. Hence, firewall here acts as a proxy between client and server. Another technique is preventing this attack is using safe reset. What happens here is, attacker sends sink packets with forged IP address which are either non-existing or unreachable, which is similar to the use of cookie. The server then replies to each connection request with sink ACK packet but never receives ACK packet because destination address in sync ACK packet is unreachable. Thus, connection stays half open until aged out. Again, an attacker sends sync packet to target server at a high speed, higher than which the connection can be aged out. As a result of which, again the TCP resources fail to provide further services to those who are legitimate users on the network. Here, the steps are as follows. Client sends sync packet to server. The firewall intercepts the sync packet and replies with sync acknowledgement packet on behalf of the server. This packet contains an acknowledgement serial number that is not intercepted by the client as well as a cookie. As a result of which, the client replies to the server with a reset packet, which is different from the cookie. The firewall intercepts the reset packet, uses the serial number in the packet for cookie authentication. If they matches, the firewall considers connection to be valid. If not, drops the packet. After the above process, the client reconnects to the server. Once this is done, normal services will not be affected even if the packets replied by the server do not pass through the firewall. Therefore, safe reset is also referred to as unidirectional proxy. That's all from the side presentation. I hope this has helped you in gaining some background knowledge about sync flood attack. Thank you.